Welcome, everyone, to the Science and Tech Podcast. I'm Joseph.
And I'm Elizabeth. And today we're diving into a topic that honestly really surprised me when I first heard about it.
Yeah, absolutely. We're going to be talking about the hidden, sometimes environmental cost of something that feels so intangible. We're talking about AI prompts, and specifically, a recent study that's really shed some light on just how carbon-intensive certain types of prompts can be.
That's right. You might think, just typing a question into an AI is like a weightless thing. But as we'll explore today, those reasoning prompts where you ask AI to show its work are surprisingly more carbon intensive than just getting a concise answer. It's quite thought-provoking.
Indeed. So buckle up because we're about to explore the carbon footprint you didn't even know your AI was making. So, Elizabeth, when we think about artificial intelligence, it often feels so ethereal, right? It's just these bits in the cloud, these lines of chat on a screen. It feels weightless, almost like it has no physical presence.
Totally. It's just poof, an answer appears. We don't really think about what's happening behind the scene.
Exactly. But here's the thing. Every single answer, every single interaction you have with an AI, it started its life as heat. Real, tangible heat inside a data center rack, And that's where the invisible footprint comes in. There was this fascinating paper, actually, published on June 19th, 2025, in Frontiers in Communication. It really made that invisible heat impossible to ignore.
Oh, I remember seeing something about that. It was a German team, right?
That's the one, led by Maximilian Downer. And what they did was pretty incredible. They timed and metered 14 popular large language models, these huge AI systems, and they tested them on 1,000 benchmark questions. They measured everything, the GPU power draw second by second, and then they converted that local grid mix into CO₂ equivalent. And what they uncovered was, frankly, a jaw-dropper. They found that prompts that specifically force an AI model to quote-unquote show its work, like when you ask it to explain its reasoning or give you steps, those kinds of prompts can actually emit up to 50 times more carbon than simple prompts that just ask for a concise, quick answer. It's quite a difference.
Wow, 50 times more? That's quite a revelation, Joseph. So how did they even figure that out? What was their methodology to measure something that feels so intangible?
Yeah, good question.
I mean, it sounds super complex, but the paper actually went into quite a bit of detail on it. They really delved into the rigorous methodology. So they hosted each of these 14 large language models on the same A100 cluster. That's, important for consistency.
Right, standardizing the environment.
Exactly. And then for every single question they asked, and they had a range, everything from what's the derivative of x squared, which is, math, to who won the 1998 World Cup, a history question. They ran these models in two distinct modes. First, there was the concise mode, where the AI just gave the final answer, no frills. And then there was the reasoning mode, where it displayed these chains of thought, like it was showing its work,
So, like the step-by-step breakdown.
Precisely. And they meticulously logged 3 key numbers for each query: the total tokens, the wall clock runtime, so how long it actually took, and crucially, the kilowatt hours consumed. That's where you start to really see the energy impact. And what they found, which I found fascinating, was this concept of thinking tokens.
Thinking tokens? What are those?
So it's the extra internal text a model generates before it even produces its final output. It's like the AI's internal monologue, its thought process. And those thinking tokens averaged around 543 per prompt when it was in reasoning mode versus, get this, only 38 in concise mode. That's a huge difference.
Oh, so it's not just the output, but the internal computation.
Exactly. It's the internal computation, the extra steps it takes to get to that show your work answer. And they essentially multiplied those tokens by the energy per token, and that's how they got that 50x spike we were just talking about. It was pretty clear. And interestingly enough, they also found that abstract algebra prompts were the dirtiest, if you will, 6 times the footprint of just straightforward history questions. So the type of question, the complexity, it really matters too.
So this study, it really it painted a pretty stark picture. It plotted what they called a grim frontier. And what they found was that, well, no model that managed to keep its emissions like below 500 grams of CO₂ per 1,000 questions, it just couldn't crack 80% accuracy.
Wow. So you're saying there's like a direct trade-off? You can't have both?
Exactly. I mean, it's pretty wild to think about. In plain English, what it boils down to is that right now, if you want those marginal gains in AI correctness, that extra bit of accuracy, it comes at a pretty significant planetary cost.
So, like, the smarter the AI gets, the more it might be, impacting the environment?
Yeah, that's exactly it. And that really sets up this pretty tough ethical dilemma, doesn't it? It impacts developers, companies who are deploying these models, and honestly, even us, everyday users who are just interacting with AI. It makes you really think about what we're optimizing for. So this study, it painted a pretty stark picture. It plotted what they called a grim frontier. And what they found was that, well, no model that managed to keep its emissions like below 500 grams of CO₂ per 1,000 questions, it just couldn't crack 80% accuracy.
Wait, so it's a straight up trade-off? Does that mean you can't have both?
Exactly. I mean, it's pretty wild to think about. In plain English, what it boils down to is that right now, if you want those marginal gains in AI correctness, that extra bit of accuracy, it comes at a pretty significant planetary cost.
So, like, the smarter the AI gets, the more it might be, impacting the environment?
Yeah, that's exactly it. And that really sets up this pretty tough ethical dilemma, doesn't it? It impacts developers, companies who are deploying these models, and honestly, even us, everyday users who are just interacting with AI. It makes you really think about what we're optimizing for.
When we hear 50 times more carbon, it's hard to really grasp that scale, right? Like, what does that actually mean in human terms?
Yeah, it sounds big, but then your brain just kind of goes, okay, but how big?
Exactly. So the study actually gives a really compelling analogy that really hit me. They said running a specific large language model, DeepSeek R1, which is a 70 billion parameter model, through 600,000 heavy reasoning prompts. 600,000? Yeah, 600,000, which is a lot, but it's not unheard of. That actually equals the CO₂ footprint of a London to New York round-trip flight, like a commercial flight.
Whoa, so just from AI prompts, that's incredible.
Right? It really puts it into perspective, doesn't it? But then, on the flip side, if you were to use a linear model like Quinn 2.5, which is a 72 billion parameter model, but you used it in that concise mode we talked about, you could ask 1.9 million similar questions for the exact same carbon bill.
So almost 2 million questions versus 600,000, all for the same environmental cost? That's a huge difference.
It's massive. So it really emphasizes that, it's not just about if you use AI, but how you prompt it. Shorter, smarter prompting really does make a significant difference. It's pretty wild to think about.
Wow, that really does put it into perspective, doesn't it? It's not just the individual prompt, but when you zoom out to, the corporate scale, the really big tech companies, that's when the numbers just swell even more.
Yeah, you start thinking about these massive data centers.
Exactly. So, for instance, Google in their 2025 environmental report, they actually boast a 12% drop in data center energy intensity. And, they credit that to their new Ironwood TPUs, which are apparently 30 times more efficient than their 2018 chips. So on paper, that sounds like really good, right? Like, oh, look, we're getting greener. But then you have this Kairos Fellowship audit, which was published actually recently, July 2nd, 2025, and they argue that Google is actually lowballing their numbers.
Oh no, so it's not as green as it seems.
Well, according to their location-based calculations, which, is a specific way of looking at it, they show that Google's emissions actually spiked 65% between 2019 and 2024. And if you go back to 2010, it's a whopping 1,515% increase.
That's a huge difference, like orders of magnitude.
I know, right? And they say this is largely driven by, you guessed it, AI workloads. So on one hand, Google's saying, look, we're cutting down. And on the other hand, this audit is basically saying, no, not really, or not as much as you think. Google, for their part, disputes these numbers. They point to market-based accounting and renewable offsets, but it really highlights just how murky AI's true environmental footprint remains. It's not as clear-cut as we might think.
Yeah, and it really just, it highlights why this reasoning mode, this show your work aspect is so much more power hungry, Like when you get into the technical side of it, these large language models, they do the bulk of their actual computing, like the really heavy lifting in what are called self-attention layers. And basically, when you ask them to reason, to show your work, it just dramatically multiplies their internal context length. So what that means is the model actually has to reread its own generated tokens again and again and again. It's not just a simple linear process.
So it's not just generating new stuff, it's reprocessing what it just made.
Exactly. It's like, okay, I thought of this. Now let me think about what I just thought and then think about that again. And this leads to what's called an n-squared cost. So it's not a linear increase, it's an exponential one in terms of GPU cycles and, obviously electricity use. More tokens, more GPU cycles, more electricity. And then you factor in the grid carbon intensity, which is still pretty high in many U.S. regions. And that climate cost just balloons. It really does.
Wow. So it's not just the output. It's all the internal processing that really racks up the energy bill. That's kind of a huge insight, isn't it?
It really is.
And I think for most of us, we're just, typing into a box and we're not thinking about that at all. But on the flip side, then, that means users actually have quite a bit of power to influence this, right? There are practical things we can do. So what are some of those strategies that, everyday users can adopt to just kind of significantly reduce their AI carbon footprint without, having to become a climate scientist? I guess first off, it makes sense. Ask for summaries. If you don't need all the details, just get the gist, right? That seems like a no-brainer now that we understand the thinking token.
Yeah, exactly. If depth doesn't really matter for your query, go for the summary.
And then, I guess, targeting smaller models first, is that a thing? If you've got access to different models, maybe don't always go for the biggest, baddest one if a smaller one will do the job.
Yeah, if you can, definitely. Escalate only if you need to. And also specifying output length, right? If you know you only need, say, under 150 words, just tell the AI that. Don't let it ramble on if you don't need it to.
That's interesting because sometimes it's you get this huge block of text and you only needed a sentence. So just being more specific, it sounds like. What about when you use it? Does time of day matter? Can you batch queries during off-peak hours or anything like that?
Yeah, that's actually a pretty smart one. If you can, batch your queries for off-peak hours because that's when the renewable energy share on the grid is typically higher. So you're tapping into a cleaner energy source potentially.
Okay, so if I'm doing a big research project, maybe I, save it for the weekend or something like that. And then this last one, caching answers. Don't regenerate what you can already store. That seems, I don't know, obvious, but probably something we don't think about with AI.
Right, like if you've already asked it something and you've got the answer, don't ask it again. Just, save it yourself. So, I mean, honestly, these are pretty simple things, aren't they? Like no coding required.
Certainly not. It's really about being mindful, which I think is a theme we're seeing. But speaking of solutions, it's not just on the user side, right? Like there are definitely technological innovations happening too.
Oh, for sure. I mean, the tech world, they're not just sitting on their hands, are they? Like, what are some of the cool, hardware and software solutions that are coming down the pipeline that might help with this?
Yeah, there are some really promising ones. So one that's interesting is called sparsity and mixture of experts. And this is essentially where instead of the entire neural network lighting up for every single token, only parts of it are activated. And early tests from Google and Anthropic are showing like 4 to 6 times inference energy reductions. So that's huge, right? Like you're making the models much more efficient.
Wow. So it's like instead of the whole brain working, it's just like the specific part of the brain that needs to work for that particular query. That's really clever.
Exactly. It's like, only sending the electricity to the parts that are actually needed. And then there's also something called algorithmic distillation. Meta's Llama Light, for example, has managed to trim their models by 70% of flops, which is a measure of computational operations, while still keeping 95% of the accuracy. So you're getting almost the same performance with a much smaller, lighter model.
That's pretty wild. Like, if you can shrink the model down and keep the accuracy, that's a win-win, really. And anything on the scheduling side, like using the grid more efficiently? Sure, definitely. Carbon-aware schedulers are a big one. Google Cloud, for example, is already delaying non-urgent AI jobs until the green energy supply rises. So basically, they're waiting for times when the grid is powered by more renewables, which cuts peak grid demand by 10%. It's pretty smart, making sure you're using the cleanest energy available.
So it's almost like, sending your laundry to run when electricity rates are lower, but it's for, climate reasons instead of just cost reasons.
Yeah, exactly. It's a really similar concept. So it shows that, it's not just up to us as users, but the tech companies are also innovating on their side.
That's such a great point, Elizabeth. Like, it's not just about what the tech can do or what we as users can do. It feels like there's also a growing push on the policy side too, right? Like regulation stepping in.
Oh, absolutely.
Yeah, I mean, I've been seeing some things about the European Commission, for example. It sounds like they're really, getting serious about this.
Yes, for sure. They have this draft called the AI Energy Transparency Act, which if it goes through, would actually require these large language model providers to publish like per query energy statistics. And, ideally they default to low carbon regions when it's feasible, which, makes total sense. Like if you can run your AI where the energy is cleaner, why wouldn't you?
That's huge. That brings so much transparency to something that's been so murky.
Exactly. And it's not just Europe either. Over here in the US, the FTC, the Federal Trade Commission, they've actually signaled a lot of interest in these greenwashing claims around AI. Remember we talked about that Kairos Fellowship audit and the Google discrepancy? That's, Exhibit A for them.
Oh, yeah, the one where the numbers just didn't quite add up between what Google was saying and what the audit found.
Precisely. So it really feels like, the pressure's mounting for more transparency, and those disclosure rules are probably going to get a lot tighter in the coming years, which, I think is a good thing. We need to know what we're actually paying for in terms of carbon. And this is where I think we get to the human side of all of this. Because, we've talked about the tech, we've talked about what we can do as users, what developers can do, what policy can do. But why should our listeners really care about this beyond, just feeling vaguely guilty about using AI?
Right. Like, what's the personal stake?
Exactly. And it's really interesting because the study actually looked into this. They found that simply displaying the CO₂ cost right there next to each AI answer, like to the beta testers, it actually nudged them to cut their prompt length by 25%. And here's the kicker, they didn't lose any satisfaction with the answers they got.
Wow. So it's not like they felt they were getting less good results, just less carbon-intensive results.
Precisely. It just shows how design choices, like the way things are presented to us, can truly transform what you might call digital guilt into like actual tangible climate action. Like you see that number, you're like, oh, maybe I don't need to ask for a 5-paragraph essay when a bulleted list will do.
That's actually really powerful. It's almost like if you see the energy cost on your appliance, you might think twice about leaving it on. It's the same principle applied to something so, seemingly ethereal like AI.
Yeah, it's about making the invisible visible.
So, to kind of bring this all together, Elizabeth, what are some of the key takeaways for our listeners from today's deep dive into AI's environmental impact? I mean, we've covered a lot.
We really have, Joseph, and I think the first big one, the headline is that your prompt style, it really, really matters. It can swing emissions by up to 50 times. And the accuracy gains for all that extra carbon, they're often pretty modest. So that show your work prompt might just be costing the planet more than it's worth sometimes.
Yeah, that 50 times number, that's just stuck with me all episode. It's truly eye-opening. And then I guess another big one, something we talked about with the Google audit, is that big tech's sustainability numbers, they're contested. Independent audits are often painting a much bleaker picture than what the companies themselves are reporting. So it's not as clear-cut as it might seem.
Absolutely. And that leads directly into our next point, which is that while hardware innovation is definitely helping, and we talked about some really cool stuff there, like the immersion cooling, user behavior, what we do every day with these tools, that's actually the fastest fix. It's the most immediate way to make a difference.
Which is quite empowering, actually. And then, it's not just on us. There's also the policy side. We're seeing increasing pressure for transparency, especially for per-query energy labels. So hopefully we'll start seeing clearer data right there in front of us, just like we discussed with the beta testers.
Exactly. And finally, and I think this is probably the most important message for our audience, is that every single AI enthusiast, really anyone who uses AI, can shrink their carbon footprint through conscious prompting. You don't need to be a coder. You don't need to be an engineer. It's about being mindful of how you ask your questions.
And that's such a powerful note to end on, Elizabeth. This has been a really insightful conversation, honestly, about something that feels so abstract, but has such real-world impact.
It truly has, Joseph, and I really hope it gives all of our listeners something to think about, when they're interacting with AI. Every prompt, every query, it just has a footprint.
Exactly. So for everyone tuning in to the Science and Tech Podcast, thank you so much for joining us today. We really hope this episode has shed some light on the hidden environmental costs of AI, and more importantly, how we can all be a part of the solution.
Yeah, and we'd love to hear your thoughts. Connect with us online, engage in the conversation, or, just consider your own AI usage. Every little bit truly helps.
Absolutely. We're going to keep exploring these fascinating intersections of technology and sustainability. So make sure to tune in next time for another thought-provoking discussion here on the Science and Tech Podcast. Until then, take care, everyone.